best options for Romex wiring in a 1915 concrete house are as follows. Firstly, consider conduit. Electrical metallic tubing, or IMT, or polyvinyl chloride, or PVC, conduit provides excellent protection for Romex wires in concrete walls. To use conduit, drill holes through the concrete and secure the conduits with anchors. The conduit must be grounded to meet electrical code requirements. Secondly, consider surface mount raceways. Non-metallic raceways are channels that can be surface mounted to the concrete walls and ceiling. These raceways provide similar protection to conduit and allow for easy wire access and maintenance. Non-metallic raceways are lightweight and easy to install. Thirdly, blocking and plywood is an option. Stripping the concrete ceiling off the basement with tuxfers and covering with plywood could be an acceptable option if done correctly. Secure the tuxfers perpendicular to the concrete joists using concrete screws. Space the tuxfers approximately 16 inches apart on center to provide adequate support for the plywood. Attach the plywood to the tuxfers using screws or nails. Leave enough space between the plywood and the concrete for air circulation to prevent mold or moisture accumulation. Fourthly, inspect and strengthen concrete. Before installing any wiring methods, thoroughly inspect the concrete walls and ceilings for any cracks or imperfections. If any cracks or damage is found, consult with a structural engineer to recommend appropriate repairs. There are some additional considerations as well. Ensure that all electrical wiring complies with the current National Electrical Code. Use Romex wires rated for the appropriate amperage and voltage. Get all wiring inspected and approved by a licensed electrician before energizing the circuits. When installing electrical wiring in a building with concrete walls, several crucial factors must be taken into account to ensure safety, compliance, and longevity. Firstly, understanding the properties of concrete is paramount. Concrete is a durable but porous material that can wick moisture. This moisture can damage electrical wiring and create safety hazards. Secondly, the National Electrical Code (NEC) provides specific guidelines for wiring in concrete and masonry structures. These guidelines are designed to protect both the wiring and the building's occupants. Thirdly, choosing the right wiring method is essential for a successful and safe installation. Several options are available, each with its own advantages and disadvantages. One common method is using conduit. Conduit is a protective tubing made of metal or plastic that encases electrical wires. It offers excellent protection against physical damage and moisture. There are several types of conduit suitable for concrete walls, including electrical metallic tubing, or IMT, rigid metal conduit, or RMC, and PVC conduit. EMT is lightweight and easy to install, making it a popular choice for many applications. RMC provides superior protection against physical damage and is often used in areas where the wiring is exposed to harsh conditions. PVC conduit is non-conductive and resistant to corrosion, making it ideal for use in damp or corrosive environments. When installing conduit in concrete walls, it is essential to ensure that it is properly supported and secured. This can be achieved using conduit clamps and anchors specifically designed for concrete. The conduit should also be installed in a way that prevents moisture from entering, such as using watertight fittings and sealants. Another option for wiring in concrete walls is using surface-mounted raceways. Raceways are channels that are attached to the surface of the wall and provide a protected pathway for electrical wires. They are typically made of metal or plastic and come in a variety of sizes and shapes to accommodate different wiring needs. Surface-mounted raceways are a good choice when it is not practical to embed conduit in the concrete. They are relatively easy to install and allow for future access to the wiring for maintenance or modifications. When using surface-mounted raceways, it is important to choose a product that is specifically designed for use on concrete walls. The raceway should be securely attached to the wall using appropriate fasteners, and the wiring should be properly supported within the raceway. Another method, using cable, such as non-metallic sheath cable or Romex, directly within concrete walls is generally not recommended. Romex is designed for use in dry locations and is not suitable for direct contact with concrete, which can be damp or wet. If Romex is used in concrete walls, it must be protected by conduit or another approved method. In some cases, it may be necessary to create a cavity within the concrete wall to accommodate the wiring. This can be achieved by furring out the wall with wood or metal studs and then covering the studs with drywall or another finishing material. The wiring can then be installed within the cavity, protected from the concrete. When creating a cavity in a concrete wall, it is important to ensure that the cavity is properly ventilated to prevent moisture from accumulating. The wiring should also be installed in a way that prevents it from coming into contact with the concrete. Regardless of the wiring method used, it is essential to follow all applicable codes and regulations. The NEC provides detailed requirements for wiring in concrete and masonry structures, and these requirements must be followed to ensure a safe and compliant installation. It is also important to obtain all necessary permits before beginning any electrical work. In addition to the wiring method, several other factors should be considered when installing electrical wiring in concrete walls. These include the type of wire used, the size of the wire, and the grounding system. The type of wire used should be appropriate for the application and should be rated for use in wet locations if necessary. The size of the wire should be sufficient to carry the intended electrical load, and the grounding system should be properly installed to protect against electrical shock. Firstly, consider moisture protection. Concrete is porous and can absorb moisture, which can damage electrical wiring and create safety hazards. Therefore, it is crucial to protect the wiring from moisture. Here are several methods to achieve this. Use conduit. Conduit provides a physical barrier between the wiring and the concrete, preventing moisture from reaching the wires. Secondly, use moisture-resistant cable. Some types of electrical cable are specifically designed to be resistant to moisture. These cables are often used in wet or damp locations. Thirdly, seal all openings. Any openings in the concrete, such as those around conduit or boxes, should be sealed to prevent moisture from entering. Fourthly, provide ventilation. Proper ventilation can help to reduce the amount of moisture in the concrete. Secondly, consider physical protection. Electrical wiring in concrete walls is vulnerable to physical damage from drilling, hammering, and other activities. Therefore, it is important to protect the wiring from physical damage. Use conduit, which provides a physical barrier between the wiring and the concrete, protecting it from damage. Secondly, use armored cable. Armored cable has a metal sheath that provides additional protection against physical damage. Thirdly, install wiring in protected locations. Whenever possible, install wiring in locations where it is less likely to be damaged, such as behind walls or above ceilings. Thirdly, consider grounding. Proper grounding is essential for electrical safety. In concrete walls, grounding can be achieved by connecting the metal conduit or boxes to the building's grounding system. Ensure that all metal conduit and boxes are properly grounded according to the NEC. Secondly, use ground fault circuit interrupters, or GFCIs. GFCIs are devices that can detect ground faults and interrupt the flow of electricity, preventing electrical shock. Fourthly, consider compliance with the National Electrical Code, or NEC. The NEC provides specific requirements for electrical wiring in concrete walls. Ensure that all wiring complies with the NEC. Obtain all necessary permits before beginning any electrical work. Secondly, have the wiring inspected by a qualified electrical inspector. Fifthly, consider future access. It may be necessary to access the wiring in the future for maintenance or repairs. Therefore, it is important to install the wiring in a way that allows for future access. Use accessible boxes. Electrical boxes should be installed in locations where they can be easily accessed. Secondly, use removable conduit fittings. Removable conduit fittings allow for easy access to the wiring inside the conduit. Thirdly, label all wiring. Labeling the wiring can help to identify it in the future. Consider thermal expansion and contraction as well. Concrete expands and contracts with changes in temperature. This can put stress on electrical wiring. Use expansion fittings which are designed to accommodate thermal expansion and contraction. Secondly, allow for slack in the wiring. Allowing for slack in the wiring can help to prevent it from being damaged by thermal expansion and contraction. Use corrosion-resistant materials as well. Concrete can be corrosive to some metals. Use corrosion-resistant conduit, boxes, and fittings. Secondly, use corrosion-resistant wire. Some types of electrical wire are specifically designed to be resistant to corrosion. When working with older homes built in 1915, there are additional considerations. You mentioned that the house was still using the original 125-volt 78-amp lighting panel. This is a clear indication that the electrical system is outdated and inadequate for modern needs. You also mentioned that someone in the late 70s installed a 150-amp panel in the basement to accommodate the stove, dryer, and heating, ventilation, and air conditioning units. This installation appears to be poorly done and may not meet current safety standards. It is essential to address these issues before proceeding with any new wiring. Upgrade the electrical service, which may require upgrading the service entrance cable, meter, and panel. This will provide the house with sufficient power to meet modern needs. Replace the existing wiring, as old wiring can be brittle and damaged, posing a fire hazard. Replacing the wiring will ensure that the electrical system is safe and reliable. Correct any existing code violations. Before installing any new wiring, it is essential to correct any existing code violations. This will ensure that the electrical system meets current safety standards. Consider the specific needs of the house. The house is 5,000 square feet and has a full basement, first floor, and second floor. All floors are 6-inch concrete, and the walls are block with 1-inch thick mortar stucco inside and out. This means that the wiring will need to be run through concrete and block walls. Take into account the layout of the house and the location of electrical outlets and appliances. This will help to determine the best way to run the wiring. Consider the aesthetic impact of the wiring. The wiring should be installed in a way that minimizes its impact on the appearance of the house. For example, wiring can be run behind walls or above ceilings to conceal it. Safety should always be the top priority when working with electricity. Firstly, disconnect the power before working on any electrical circuits. Secondly, use insulated tools. Thirdly, wear safety glasses. Fourthly, work with a qualified electrician. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. When dealing with a house built in 1915 with concrete and block walls, the electrical rewiring presents unique challenges. Firstly, assessment of the existing electrical system is important. Begin with a comprehensive assessment of the existing electrical system. Pay close attention to the condition of the wiring, the capacity of the electrical panel, and the presence of any code violations. Secondly, planning the new electrical layout is important as well. Develop a detailed plan for the new electrical layout, taking into account the needs of each room and the location of outlets, switches, and lighting fixtures. Consider future expansion and ensure that the electrical panel has sufficient capacity to accommodate future needs. Thirdly, consider wiring methods for concrete and block walls. Given the concrete and block construction, carefully consider the wiring methods that are best suited for these materials. Conduit is a common choice for running wires in concrete and block walls, providing protection against physical damage and moisture. Surface-mounted raceways can also be used, offering flexibility and ease of installation. Fourthly, installing conduit in concrete and block walls should be considered. If using conduit, carefully plan the routing and installation. Drill holes through the concrete or block walls to accommodate the conduit, ensuring that the holes are properly sized and aligned. Secure the conduit to the walls using appropriate anchors and fasteners. Fifthly, consider surface-mounted raceways. If using surface-mounted raceways, choose a product that is specifically designed for use on concrete or block walls. Secure the raceways to the walls using appropriate fasteners, ensuring that they are properly aligned and level. Sixthly, wiring the outlets, switches, and lighting fixtures is important. Once the wiring is in place, connect it to the outlets, switches, and lighting fixtures. Follow the NEC guidelines for wiring connections and grounding. Seventhly, grounding the electrical system is important. Ensure that the electrical system is properly grounded to protect against electrical shock. Connect all metal boxes, conduit, and equipment to the grounding system. Eighthly, testing the electrical system is important. After completing the wiring, thoroughly test the electrical system to ensure that it is working properly. Use a multimeter to check for voltage, continuity, and proper grounding. Ninthly, consider inspections. Obtain all necessary inspections from the local building department to ensure that the electrical work meets code requirements. Tenthly, documentation is important. Keep detailed records of all electrical work, including wiring diagrams, inspection reports, and permits. This documentation will be helpful for future maintenance and repairs. Here are some additional tips for rewiring a 1915 house with concrete and block walls. Consider using a qualified electrician with experience in working with older homes and concrete and block construction. They will be familiar with the challenges involved and can ensure that the wiring is done safely and correctly. Secondly, be prepared for unexpected problems. Rewiring an old house can often uncover unexpected problems, such as hidden wiring, damaged insulation, or code violations. Be prepared to address these problems as they arise. Thirdly, take your time. Rewiring a house is a complex project that should not be rushed. Take your time to plan the project carefully and to execute it properly. Fourthly, be patient. The rewiring process can be disruptive and time-consuming. Be patient and work closely with the electrician to minimize the disruption and to ensure that the project is completed to your satisfaction. The project should address the outdated 125-volt panel and the haphazard 150-amp installation. Bringing the electrical system up to modern standards is crucial for safety and functionality. The question mentions using tooksfors and plywood to protect the wiring. While this approach can be used, it is essential to ensure that it meets code requirements and provides adequate protection for the wiring. When securing the tooksfors to the concrete ceiling, use concrete screws or anchors that are specifically designed for this purpose. Space the tooksfors appropriately to provide adequate support for the plywood. When attaching the plywood to the tooksfors, use screws or nails that are long enough to penetrate the tooksfors but not so long that they damage the wiring. It is also important to leave enough space between the plywood and the concrete to allow for air circulation and prevent moisture buildup. In addition to the wiring methods mentioned, it is also important to consider the type of wire that is used. Use Romex wires that are rated for the appropriate amperage and voltage. Ensure that the wires are properly sized for the circuits they will be serving. Finally, it is essential to get all wiring inspected and approved by a licensed electrician before energizing the circuits. This will ensure that the wiring meets code requirements and is safe to use. Rewiring a 1915 house with concrete and block walls is a challenging but rewarding project. By following the tips outlined above, you can ensure that the wiring is done safely, correctly, and in compliance with code requirements.